Look at the change in your pocket. A single coin. Two faces stamped into the same piece of metal, opposite sides, born in the same press, pinned together back to back. The early universe was a machine that did exactly that. It stamped out matter and antimatter in pairs, twins identical in every way but one, opposite charges pressed into existence together, billions of pairs, faster than you can blink. But these twins have a rule. When one touches the other, they don't fight. They vanish, both of them, gone in a single flash of light. So by every law we know, the universe should have erased itself. Every particle cancelled by its twin, a clean, empty sky with nothing in it but a fading glow. No coins, no pockets, no you. Instead, for every 1 billion pairs, exactly one particle of matter was left standing. One. Out of a billion. Loose change the universe forgot to spend. And every star, every ocean, every atom in that coin, and in the hand holding it, was built from that single leftover. 1 billion to 1. The universe almost deleted itself and missed by a rounding error. Honestly, we should be grateful it's bad at math. A clean explosion leaves nothing behind. So why is there a coin in your hand at all? Picture the early universe as a factory running at impossible speed. Every microsecond it stamps out particles, and beside each one an exact mirror twin with the opposite charge. Matter, antimatter, matter, antimatter, billions of pairs, faster than you can blink. The factory has one rule wired into it. Physicists call it symmetry. Matter and antimatter are supposed to be perfect opposites, treated identically by every law of physics. Flip the mirror and the universe should look exactly the same. If that rule held, the story ends right here. Every particle finds its twin, they cancel, and you get a sky of light and absolutely nothing else. No matter, no floor under your feet. Then, in 1964, two physicists, James Cronin and Fitch, caught the rule breaking. They were studying tiny particles called kaons, and they spotted something that wasn't supposed to be possible. The matter version and the antimatter version decayed just slightly differently. Not dramatically. A whisper. That whisper won them the Nobel Prize in 1980. That whisper is the crack in the mirror. The universe does not treat matter and antimatter perfectly equally after all. Something tilts the scale, barely, toward matter. A few years earlier, in 1967, a Soviet physicist named Andrei Sakharov had already written down the 3 conditions that had to be true for matter to win at all. We've checked them since. All 3 appear to have happened, and we still can't reproduce the result. Because here's the part nobody likes to say out loud. That crack Cronin and Fitch found is real, and nowhere near big enough. Run the numbers, and the known tilt explains a tiny sliver of the leftover matter. The rest, the part that built basically everything you have ever seen, comes from physics we have not discovered yet. 60 years of looking. The universe filed the rest under "figure it out yourselves." So we know the mirror cracked. We still have no idea what threw the stone. Now here's where it stops being a fun fact and starts being genuinely uncomfortable. That leftover, 1 in a billion, wasn't just lucky. It was tuned. Shrink the surplus a little, and the early universe comes out too thin. Matter never clumps, stars never ignite. And no stars means no furnaces to forge carbon, oxygen, iron, the stuff you're made of. No furnaces, no planets, no chemistry, no you. Just cold fog forever. Now push it the other way. Make the surplus a little bigger, and there's too much matter. Gravity pulls too hard, too fast. Stars flare up and burn out in millions of years instead of billions. Gone long before a planet has time to cool, let alone grow anything that breathes. 1 in a billion is the exact number that sits in the doorway between those 2 dead universes. And every time physicists sharpen their models, that doorway gets narrower, never wider. Stop. Sit with that for a second. The existence of everything, balanced on a margin thinner than 1 part in a billion, set in the first second, with no chance to adjust it afterward. 60 years. That's how long the smartest people alive have been staring at this one number, trying to explain why it isn't 0. 60 years, and the most honest answer is still, we don't know. We know what precision like that costs, because we've tried to reach it. At CERN, the most advanced machine our species has ever built, $13 billion and more than 10,000 scientists can trap a few hundred atoms of antimatter for about 15 minutes. The newborn universe handled more antimatter in a microsecond than we'll make in 1,000 years, and walked away with the books balanced to the 9th decimal. Randomness, apparently, sat the engineering exam and outscored CERN. So here's the question that should keep you up tonight. How does an explosion, a blind, screaming burst of raw energy, leave behind a number that looks chosen? Now imagine we actually understood it, that we could make antimatter the way the universe did on demand. Antimatter is the most powerful fuel physics allows. When matter and antimatter meet, they don't burn, they convert. 100% of their mass becomes pure energy. Compare that to the rocket that carried humans to the moon. It turned less than 1% of its fuel into thrust. Even nuclear fusion, the prize we still can't tame, tops out around 0.7%. Antimatter is in a different universe of efficiency, literally. NASA's Jet Propulsion Laboratory has run the numbers on this. A few grams of antimatter, just grams, could drive a spacecraft to Mars in about 6 weeks. Chemical rockets need 7 months. This isn't a fantasy. It's an engineering blueprint sitting on a shelf, waiting for a fuel we can't manufacture. And that's the humiliation. CERN makes antimatter a few thousand atoms at a time. To gather a single gram at that rate would take longer than the universe has been alive. We've effectively spent the age of the cosmos in effort, and we're not close. It's not all theory either. Walk into a hospital today, and a PET scan already uses tiny bursts of antimatter to map a living brain and catch tumors early. We use the stuff. We just can't make it, can't store it, can't explain it. 3 for 3. In 2023, after decades of work, CERN finally confirmed something almost embarrassingly basic. Antimatter falls down under gravity, like everything else. That made headlines. The universe had settled the entire matter-antimatter ledger before the first second was over. We call this an open problem. The universe called it Tuesday, so let's lay it out plainly. A universe that should have erased itself. A flaw in the mirror no one can fully find. A leftover of 1 part in a billion, not too much, not too little, sitting in the exact doorway that allows stars, planets, and breathing things to exist. Set in the first second, never adjusted, balanced to a precision the best machine we've ever built cannot copy or even explain. Every atom in your hand came through that doorway. You are made entirely of the part that was supposed to be cancelled. Physics has a polite word for a number this exact with no known cause. It calls it a coincidence. But a coincidence this fine, set this early, holding for 13.8 billion years, at some point the word stops being an answer and starts being a place we hide. So here's the only question left. Who balanced the books to 1 in a billion, if no one was counting?